A crime scene, a place of chaos and sorrow. The air is thick with tension, and the ground is littered with the remnants of a violent act. It's a scene that tells a story, but not in words. Instead, it speaks through the silent crimson marks left behind. But amidst the disorder, there are silent witnesses waiting to be heard. These witnesses are not people, but rather the bloodstains that paint a vivid picture of the events that transpired. Each stain, each drop, holds a piece of the puzzle, waiting to be deciphered by those who understand their language. Their stories are written in a language most macabre, the language of blood. This language is not spoken, but rather observed and analyzed. It is a language that requires a keen eye and a deep understanding of the science behind bloodstain patterns. Every drop, a whisper, every splatter, a scream. The patterns they form can reveal the direction of the force, the type of weapon used, and even the movements of the victim and perpetrator. It's a silent testimony that, when interpreted correctly, can speak volumes. To the untrained eye, it may seem like nothing more than a gruesome stain, but to those who have dedicated their lives to studying these patterns, it is a window into the past. It is a key to unlocking the truth behind the crime. But to a bloodstain pattern analyst, it's a window into the past, a key to unlocking the truth. These analysts use their expertise to reconstruct the events that led to the bloodshed, providing crucial insights that can make or break a case. Blood is an essential part of life. It courses through our veins, carrying oxygen and nutrients to every cell. It is a symbol of vitality and health. But in the context of a crime scene, it takes on a much darker significance. But when violence erupts, blood transforms from a symbol of life to a chilling reminder of mortality. It becomes a stark indicator of the violence that has occurred, marking the scene with its unmistakable presence. It stains the ground, the walls, the very air with the weight of the act committed. The sight of blood can evoke a visceral reaction, a reminder of our own fragility and the thin line between life and death. Yet, in its tragic permanence, it also offers a unique opportunity. An opportunity to understand the sequence of events, to piece together the narrative of the crime, and to bring justice to those affected. An opportunity to understand what happened, how it happened, and who was responsible. Bloodstain pattern analysis provides a roadmap for investigators, guiding them through the complexities of the crime scene. For centuries, bloodstains remained largely unexplored as a source of forensic evidence. Early investigators acknowledged their presence but lacked the tools and knowledge to fully comprehend their significance. Investigators acknowledged their presence but lacked the knowledge to fully comprehend their significance. It wasn't until the advent of modern forensic science that the true potential of bloodstain pattern analysis was realized. However, as our understanding of science and human behavior advanced, so too did our ability to decipher the cryptic messages hidden within these crimson patterns. The development of new techniques and technologies has revolutionized the field, allowing for more precise and accurate interpretations. Today, bloodstain pattern analysis stands as a cornerstone of forensic science, providing crucial insights into some of the most perplexing criminal cases. It is a discipline that continues to evolve, driven by the relentless pursuit of truth and justice. Bloodstain pattern analysis, or BPA, is the meticulous study of bloodstains found at a crime scene. This scientific method is crucial in modern forensic investigations, providing insights that are often invisible to the naked eye. It's a forensic discipline that utilizes scientific principles to extract valuable information about the events that led to the bloodshed. By understanding the physics of blood, analysts can determine how and why blood was deposited in certain patterns. Analysts examine the size, shape, distribution, and location of bloodstains to reconstruct the sequence of events and gain a deeper understanding of the crime. Each bloodstain tells a part of the story, and when pieced together, they reveal a comprehensive narrative of the incident. The roots of BPA can be traced back to the late 19th century, with pioneering studies exploring the behavior of blood droplets. Early forensic scientists were fascinated by how blood behaved under different conditions, laying the groundwork for future advancements. However, it wasn't until the latter half of the 20th century that BPA emerged as a recognized forensic discipline. The development of more sophisticated techniques and tools allowed for more precise and reliable analysis. The seminal work of experts like Dr. Herbert Leon McDonnell, often hailed as the father of bloodstain pattern analysis, established a scientific framework for this field. His research and publications provided a foundation that modern BPA continues to build upon. BPA is not merely about identifying the source of the blood. It involves a detailed examination of the bloodstains to understand the dynamics of the crime. It delves deeper, seeking to answer crucial questions. For instance, analysts can determine the direction from which the blood originated, the force used, and even the type of weapon involved. What was the weapon used? Was it a blunt object, a sharp instrument, or perhaps a firearm? Each type of weapon leaves a distinct pattern that can be identified through careful analysis. How many blows were struck? The number of impacts can often be determined by the number of distinct bloodstain patterns present at the scene. What was the position of the victim and the assailant? By analyzing the angles and trajectories of the bloodstains, experts can reconstruct the positions and movements of those involved. These are just a few of the mysteries that BPA can help unravel. The discipline combines elements of biology, physics, and mathematics to provide a scientific basis for crime scene reconstruction. By meticulously analyzing the silent language of bloodstains, investigators can piece together a more complete picture of the crime and bring perpetrators to justice. This powerful tool in forensic science continues to evolve, offering new ways to solve even the most complex cases. The science behind BPA lies in understanding the physical properties of blood and how it behaves when subjected to external forces. Blood, despite its liquid nature, possesses a degree of viscosity, surface tension, and cohesion that influences its movement and the patterns it forms. Experts in BPA employ a range of scientific methods and tools to analyze bloodstains. Photography plays a crucial role, allowing for detailed documentation and analysis of the patterns. High-resolution images capture even the most minute details, enabling analysts to study the shape, size, and distribution of individual stains. Furthermore, advanced techniques like luminol testing help reveal hidden bloodstains invisible to the naked eye. One of the fundamental principles of BPA is the relationship between the force applied to blood and the resulting spatter pattern. A low-velocity impact, such as a blow from a fist, typically produces larger, more elliptical bloodstains. In contrast, a high-velocity impact, such as a gunshot, generates a fine mist of tiny blood droplets. By carefully examining the characteristics of the spatter, analysts can determine the force and direction of the impact, providing crucial insights into the nature of the assault. Bloodstains are not created equal. Each bloodstain at a crime scene holds a unique story, a silent witness to the events that transpired. The meticulous study of these stains can unravel the sequence of actions, the nature of the crime, and even the identities of those involved. The shape, size, and distribution of bloodstains can vary dramatically, depending on a multitude of factors, including the type of weapon used, the force of the impact, the distance traveled by the blood, and the surface it lands on. Each variable adds a layer of complexity to the analysis, making the role of forensic experts crucial in piecing together the puzzle. Understanding these different types of bloodstains is paramount to accurately interpreting the story they tell. Forensic investigators spend countless hours studying these patterns, using their expertise to decode the silent messages left behind. This knowledge can be the difference between solving a case and leaving it shrouded in mystery. Passive bloodstains, as their name suggests, are formed by the force of gravity alone. These stains are typically found in the form of drops, flows, and pools of blood. Their shape and distribution can often indicate the position of the victim at the time of injury, providing crucial information about the events leading up to the crime. These typically include drops, flows, and pools of blood, and their shape can often indicate the position of the victim at the time of injury. For instance, a pool of blood might suggest that the victim was stationary for a period, while a trail of drops could indicate movement, perhaps an attempt to flee or seek help. Transfer bloodstains occur when a blood-bearing surface comes into contact with another surface, leaving behind a bloody imprint. These stains can be incredibly telling as they often capture the shape of the object or body part that made contact, such as a handprint, a shoe print, or even the pattern of a fabric. This could be anything from a handprint to a shoe print, providing valuable clues about the movements of individuals at the scene. The direction and clarity of these prints can help reconstruct the actions of both the victim and the perpetrator, offering insights into the struggle or escape attempts. Spatter stains, on the other hand, are created when blood is dispersed through the air as a result of force. These stains are often more complex, with patterns that can reveal the dynamics of the violent event. The analysis of spatter can help determine the type of weapon used, the number of blows, and the positions of the individuals involved. These stains can be further categorized into impact spatter, cast-off spatter, and arterial spurting, each with its own unique characteristics. Impact spatter results from a forceful blow, cast-off spatter occurs when blood is flung from a weapon, and arterial spurting is caused by the breach of a major artery, each telling a different part of the story. Impact spatter, often the most telling, results from blood being dispersed when a force strikes a blood source. The size and distribution of these droplets can indicate the intensity of the force, the type of weapon used, and the relative positions of the victim and the assailant at the moment of impact. The size and shape of the spatter can indicate the force of the impact, the type of weapon used, and even the relative positions of the victim and the assailant. By meticulously analyzing these patterns, forensic experts can reconstruct the sequence of events, providing a clearer picture of the crime and aiding in the pursuit of justice.